Lesson 4.2, Weight and Drag Forces. So in this lesson, we're going to be focusing on weight, especially inside of elevators, and drag forces, like for example, when you're skydiving. So first off, it's important to note the difference between weight and mass. So you have weight here, and you have mass on this side, and the difference between them. So mass is how much matter inside of a certain object, and it's denoted by kg. And the mass of an object doesn't change due to forces. Now, weight, on the other hand, is your mass multiplied by the gravitational force. This is equal to your weight. And your weight can change depending on the amount of forces acting on it. And the perfect example of this is on an elevator. When you're on an elevator, you'll notice that when you're going upwards, you'll feel heavier, right? When you go upwards like 12 to 11 floors from floor 1 till floor 12, you're going to feel heavier because of the elevator. And same thing when you go downwards, you're going to feel lighter. You're going to feel like maybe 10 kg lighter or less even, 5 kg lighter, depending on how fast the elevator is moving. And this is the difference between mass and weight. So weight can change depending on the situation you're in, but mass, on the other hand, won't change because of forces. And weight is also measured in newtons, and mass is measured in kgs. So a lot of the times when you want to measure your weight, you'll use something called a scale. Now, a scale usually measures your weight in terms of kgs, which actually isn't true. Like for example, the scale would say here you're 50 kg or something, but in reality, it's converting your weight by dividing it by 10. So your weight is like 500 newtons, and it divides it by 10 to give you your mass. And it tells you your mass. It doesn't actually tell you your weight. So 50 kg is your mass. Now, how does a scale actually measure your weight? So if a person stands on this scale, what are the forces acting on the scale? So I have the scale right here. There's the force of you applying the force on the scale, like I stand on top of it. You have the force Fg downwards on the scale, and the scale also applies a force equal to your force on the ground. So the force, and this force is called we'll call it Fs. So force of scale. So Fs. And how it measures it is it basically just tells you how much force or how much newtons your weight is exerting, and it just writes it down like on the number. Now this is only when you're at rest, right? Now what if the scale is on an elevator? Like I'm on an elevator, and I decide, right, it's an elevator, and I decide that I want to use a scale while the elevator is moving upwards or downwards. What's going to happen to my weight? So there are 3 cases when you're on an elevator. The first case is when you're in constant motion or constant velocity. So, right, I have the scale. It's on this elevator. And whenever there's a scale in an elevator, there's Fg downwards. The force, I'm sitting on it, right? I'm standing on the scale. There's going to be your Fg, which is going to be downwards. And there's going to be a force upwards called the force of the scale, denoted by Fs. So if I'm at constant velocity, what does that mean? Simply means that my acceleration going to be equal to 0. So if I want to calculate my mass, I want to calculate, not my mass, sorry, my weight, and I want to calculate my weight right now, well, it's going to be simple. It's going to be Fnet, it's going to be Fnet equal to mass times acceleration. But mass and acceleration, if acceleration is 0, then these two are just going to be 0. And my Fnet is going to be equal to this and this. So let's calculate this and this alone. Simply doing Fs. So Fs is upwards, so it's positive. So Fs, and then minus Fg, which is downwards. Now, if for example, let's say I weigh 60 kgs. This is my mass. So 60 times 10 is equal to my Fnet. So the Fnet is going to be equal to Fs minus 600. And if I do it correctly, and I substitute this in my formula, so I'm gonna take this Fnet and I'm gonna substitute it into my Fnet is equal MA formula. And this is going to be equal to Fs minus 600 equal to MA, but MA is 0. So Fs minus 600 equal to 0 plus 600 plus 600. And my Fs, so the force on the scale will read 600 newtons. Did my weight change? No, because my weight is 600, right? 60 times 10 is my actual weight, and the scale also reads 600. So my weight didn't change, right? So when it's at constant velocity, my apparent weight read on the scale won't change. So that's the first case. Let's look at the second case. So the second case, I have a scale again, and we'll keep the same mass throughout. So m is equal to 60, so we can see the differences. So the second case, we're going to have the acceleration equal to 2 meters per second squared. What does that mean? And I'm positive, so it's going to be upwards, and it's going to be speeding upwards, right? When I have an acceleration of 2 meters per second squared, that means I'm going to go upwards, and I'm also going to be speeding up, right? Because it's positive. So that means I'm speeding upwards. There's 4 other cases, so we should know how to calculate and how to know this. So here are the 4 cases. I'll quickly say them. So plus is speeding upwards. Plus minus. So the left side will be speed, and this will be the direction. I mean, this will be if I'm speeding up or slowing down, you know, speeding up or slowing down. And this will be my direction. So if I'm speeding up with my direction being negative, that means I'm speeding, that means I'm slowing down. I'm slowing down, and I'm slowing down in the I'm speeding up in the negative direction, sorry. In the speeding downwards, so in the negative direction. Now if I have minus and plus, that means what? I'm speeding up, I'm slowing down, but in the positive direction. So it's like I'm going on an elevator, but the elevator is going upwards, but it's slowing down. Upwards. And then finally, you have minus, and I'm slowing down in the negative direction. So that means I'm slowing down, I'm going downwards, and I'm also slowing down. So I'm like coming to a halt downwards. So those are like the 4 cases. So here I'm speeding up, and my acceleration is positive, so I'm speeding up upwards. So what happens when I'm speeding up upwards? We can calculate the Fs. So we have Fg downwards again, and we have Fs upwards. So we can calculate the Fnet MA. The Fnet, of course, is going to be the same thing. It's going to be 600, Fs minus 600. So we can simply just substitute it again. Fs 600 to the mass. Now this time acceleration isn't 0, so we can't just cross it out. So it's going to be equal to 60 times 2. And if we calculate it using a calculator or anything, we're going to see that our apparent weight, and I'll tell you why it's called the apparent weight, going to be equal to 720 newtons. Now, what happened to our weight here? Before it was 600 newtons. Here, Fs was 600 newtons. But now it increased by 120 newtons. That means that the scale actually didn't read a correct read. Our weight changed. So it's not actually reading our mass, it's reading our weight. And our weight here changed, and it was increased by 120 newtons. So it appears that I'm heavier, basically. So that's my apparent weight. This is my real weight. Now the final case, same mass, but this time we're going to say our acceleration is going negative. So minus 2 meters per second, and we're going upwards still. So minus 2 meters per second, and we're still going upwards. So what does this mean? Negative and then the positive direction. That means we're slowing down in the positive direction. So slowing down in the upwards. So we'll draw our scale again. We'll write it here. So we're slowing down upwards. So minus here, that's for the acceleration, and upwards is the direction. So Fs here, and Fg down again. And we can still calculate our Fnet. We'll do the same formula. And we're going to see the difference this time with a negative acceleration. So Fs is 400, Fs is Fs minus 600, and it's equal to 60 multiplied by, this time it's negative 2. And if we calculate it, we're going to get an Fs to be equal to 480 newtons. This time, our weight decreased. So we appear to be lighter when it's slowing down upwards. And this is actually true. If you recall, when you go in an elevator and it slows down, so it's reaching its destination, you're going to feel like you're lighter. You're going to feel like you're kind of floating a little bit when you arrive at the spot that you want to be. So whenever you actually solve elevator questions, you can just imagine the feeling of being in an elevator, and you'll be able to know if you're either going to feel heavier or lighter. So to quickly re-explain the ideas mentioned in the elevator, this idea wasn't exactly explained well. So to go over it, speeding up, slowing down, speeding up, down, and slowing down. So there are 4 different cases, of which you either feel heavier or lighter. So when you're speeding up, that means you're accelerating positively. So A will be positive, and upwards is in the upwards direction, so it's also positive. So when both values are positive, that means you're going to feel heavier. So heavier. Now in the second case, slowing down means you're going to be negatively, right? The acceleration is going to be equal to a negative value. And then upwards is still positive. So that means that I have a negative value and a positive direction. So when you have a negative and positive, you're going to feel lighter. So the next case, speeding up downwards, that means acceleration is going to be, speeding up is positive, so acceleration is going to be positive, and downwards is negative. So you have a positive value and a negative value, and these together, when you're speeding up downwards, you're going to feel lighter. And finally, when you're slowing down downwards, so let me just write down again. So slowing down is negative, and downwards is also negative. So what happens is you have two negative values, and when you're slowing down downwards, you feel heavier. So those are the 4 cases, and you should know when you feel lighter and when you should also feel heavier. So the next idea is going to be drag force. And drag force is the the resistance an object experiences when traveling through a fluid. What this means is, for example, if you drop a ball from the top of a building or something, uh, it's going to experience less drag force than, for example, if you drop a paper. If you drop a paper, it's going to like flow like this and then like that. It's going to eventually reach the ground. This is drag force, and it's a lot greater than the force when you throw a ball. Now, why is it greater? Because the paper has a greater surface area. And drag force increases with the increase of surface area. So, for example, if you know when a person parachutes or he glides, his parachute has a very great surface area. It's like very thin, but the parachute itself is like very large in surface area, which resists the force of gravity downwards. So that's how they resist the force of gravity. You have a drag force that's extremely high that resists the force of gravity. There's another example when you're running. When you run, that's not running. Doesn't matter. When you're running and you go towards like this direction, you'll experience a lot of drag force because when you run through the air, you're running through some kind of fluid, right? The atmosphere is fluid, like air is gas, and it's going to resist the movement of which you're running, which is why you experience like a wind on your face when you run. That's drag force slowing you down. So the final point we have for this lesson is going to be terminal velocity. Terminal velocity occurs only when you're in free fall. So for example, a man is parachuting. He's going to eventually reach a velocity, and it stays the same. It's like 20 meters per second or something. And he's going to have a velocity of 20 meters per second, and he won't accelerate anymore. So acceleration is going to be equal to 0. Now, when does this happen? So let's look at the trip of a skydiver. So skydiver starts at the plane. Here's the plane. Let's draw like plane. And he jumps off, right? And now he's going to end up being over here. And he's falling through the air. And he's going to accelerate, right? By 9.8 meters per second squared, right? Free fall. And he's going to continue accelerating until some point where his velocity is going to reach a point, like for example, he reaches 50 meters per second squared, 50 meters per second, his velocity. V is equal to 50 meters per second. He just stops accelerating. And how does this happen? It's because there's a force acting on this person. There's a force acting on this object. There isn't just gravity acting on this object. There's also the force of air resistance, or drag force, right? So you have the force of Fg downwards, and you also have the force of drag force upwards. And at the beginning, your drag force isn't that much, but eventually, your drag force is going to be like maybe, if you weigh like 50, then you have a Fg of 500 newtons, and your drag force would be like some kind of a value less than this. But eventually, your drag force will start to increase. And since your weight won't increase, you're going to start, you're going to stop accelerating as much. And eventually, you're going to reach a point, perhaps here, where the drag force is actually equal to the force of gravity downwards. And at this point right here, this is when you've reached terminal velocity, where, for example, you have a velocity of 50 meters or 60 meters per second. And it doesn't increase or decrease. It just stays constant. And you continue falling all the way to the ground until you reach the ground at 60 meters per second. And when this happens, when the drag force is equal to your gravitational force downwards, and they cancel out, so there's no unbalanced forces, and you just remain at a constant terminal velocity of whatever force, whatever speed you were going at. So the first question we're going to go over is this one where a person is standing on an elevator. So it's an elevator, and in which of the following cases will the person feel lighter? So we said there are two cases where you'll feel lighter, either when you're speeding up and you're slowing down. So you have acceleration is positive, and you're slowing down you're in the positive direction. So your acceleration is negative, but you're going upwards. So this is slowing down upwards. So, and that's the first case. And the second case is when you're speeding up downwards. So speeding up is positive and downwards is negative. Slowing down is negative, speeding up is positive. Slowing down is negative and upwards is positive. So the elevator speeds up while moving upwards. So positive and positive, it's going to be wrong. So the elevator slows down while moving upwards. So slowing down is negative and moving upwards is positive. So that could be an answer. The elevator moves up with a uniform speed. Here there's no acceleration at all, right? Uniform speed means acceleration is equal to 0. So you won't feel lighter or heavier. You're just going to feel like your normal weight. So this is going to be wrong. And finally, the elevator moves down with uniform speed. Again, uniform speed is going to be equal to acceleration equals 0. So you won't change your weight. So the only case is B, where you slow down and you're going upwards. So this is the correct answer. So for the next question, you place a watermelon on a scale and it's calibrated to measure your weight in newtons. So you have a scale and you have a watermelon on it. It's a watermelon. And its weight is in kgs, so 4 kgs. So what the question is, what is the scale's reading? So if you remember correctly, the scale has gravity downwards. So the watermelon is applying a force on the scale downwards, and the scale is also applying a force upwards called Fs. So we can simply calculate the scale's reading by calculating the F net, which is equal to Fs, which is upwards, minus, you can do it in the same color, Fs, and then minus Fg. So Fg is 4 times 10. 4 times 10. Why is it 4 times 10? Because if you remember, Fg is equal to mass times gravity, and gravity is constant, so 10. So you have 4, so it's going to be 4 times 10. So the F net to be equal to Fs minus 40. Now, there's something you should note here. If the watermelon is just standing there, sitting there, then there is no movement, right? That means that F net should be equal to 0, right? Because the watermelon is standing on a scale and it is not moving. It doesn't say it's moving anywhere. It's just sitting on the scale. So whenever there's no motion, the velocity is going to be equal to 0 and the acceleration is going to be equal to 0. So an F net is also going to be equal to 0. Knowing this, we can say that 0 is equal to Fs minus 40. So negative Fs is equal to minus 40. So Fs is going to be equal to 40 newtons. That is what the scale is reading right now, 40 newtons. So for this next question, it says that an object is dropped from a large height. So you have a height here of x height, and it's dropped from this height. So it's dropped, and large height above the ground and takes a very long time to reach the ground. So it takes a very long time to reach the ground, and the only forces exerted on the object, so the only forces exerted on the object are the force of Earth's gravity and the force of friction exerted by Earth's atmosphere. So the force of friction exerted by Earth's atmosphere is also called drag force or air resistance. So this object has, let's draw a free body diagram. So it has what? It has Fg downwards, and it also has the force of friction or drag force Fs. Now, we don't actually know how big it is yet. This is just at the beginning. So at the beginning, it would look something like this. So a graph of the object speed versus speed as a function of time is shown. So here's the graph. And it asks which of the following claims best describes the force of friction exerted on the object. So first of all, we should know that it started here, right, with velocity 0, so at the top of this hill, at time 0. And then what happened? The velocity slowly started to increase as time went by, and then, it just stopped increasing, and it became a constant line. So what happened here is that there is something called terminal velocity, and the object eventually became in a state of terminal velocity where the Fs is going to be equivalent or equal to the Fg, so equal. And then this equals terminal velocity. So the answer is going to be this. So it's initially 0, right here, and it increases its magnitude over time until it balances the force of gravity. So the force of friction eventually balances the force of gravity. So for this next question, we have a 40 kg girl. So the mass is 40 kgs. And she stands on a scale in an elevator. So there's Fg downwards and Fs upwards. So first of all, we need to find the reading of the scale if the elevator is speeding up while moving upwards. So speeding up, meaning that the acceleration is positive, and while moving upwards as well, so the direction is also positive. Oh, he gave us a number, so it's 2 meters per second squared. So positive 2 meters per second squared upwards. So we immediately already know that the person is going to feel heavier, but we need to find the reading of the scale. So first we find F net equal to Fs minus Fg. Fg is 400. Fs, this is 40 times 10. So 400. And we have F net. So we can use the formula F net is equal to ma and substitute this here. And we have Fs minus 400 is equal to the mass, which is 40, times the acceleration, which is 2. And this will give us the reading of the scale equal to 80 plus 400. So Fs is going to equal to 480 newtons. So for this next question, we have a person with a mass of 85 kg. So m is equal to 85 kg. And he steps onto an elevator. Now it wants to know the scale reading if the elevator slows. So slowing down means acceleration is equal to negative, and at a rate of 2.5 meters per second. So negative 2.5 meters per second squared, and it moves upwards, meaning that the person is going to feel lighter. So how do we calculate it? First of all, we get the F net is equal to Fs minus Fg, and F net is going to be equal to 85 times 10. So 85 times 10 is 850. Now we can use the formula F net is equal to ma. Substitute this here. And we'll use formula with acceleration of negative 2.5, so the mass is going to be 85 times negative 2.5, and you're going to get an answer you're going to get an answer which is equal to 637.5 newtons. So you can see this is his apparent weight. His real weight is actually 850 newtons. But his weight decreased, so he feels lighter. So for this final question, we have a parachutist with a mass of 70 kgs, and we can draw him. Here he is. And he's falling vertically, so there's Fg downwards at a constant speed of 8. So velocity is going to be 8. Wait. It says he's falling at a constant speed, meaning that the acceleration is also 0. So what is the magnitude of the total upwards drag force? So it wants to know the drag force acting on it. So Fd. So that's drag force. D is for drag force. Now, so it's important to note that when you're falling vertically, so when you're free falling, and you're at a constant speed, that also means that you're at terminal velocity. And if you remember, when you're at terminal velocity, that means that the drag force is going to be equal to your weight. So it's important to note that. We can also do it mathematically. So if we do it this way, then we know that the mass times gravity is equal to weight, or Fg. So we can just find it using 70 times 10, which is equal to 700 newtons. Now we can find the answer like this, or if we want to do it mathematically, we can do Fnet is equal to ma. Since acceleration is 0, ma will be 0, and then we have Fnet with Fg, Fd minus Fg is equal to 0. Fd is going to be unknown, and Fg is, we already know it, it's 700 newtons, equals 0, and then plus 700 plus 700. And then we get the total drag force, which is 700 newtons. That's the answer. Both ways work, just depends on how you interpret the question. That'll be it for lesson 4.2, weight and drag force. If you have any questions or want to ask anything at all, you can ask it down below in the comment section or in the Discord server. And yeah, good luck.